come up?
I think that this one, it's like, I think it's just that instead of like the water.
That's an odd thing.
Or maybe it could be the liquid inside.
Do you think there's
Wait a
something
minute.
inside?
Yeah.
I feel like
Are
there's
they
something.
all?
I feel like there's something at the top because this one's kind of like floating in a way.
You think it's a defective can, maybe? Could there be a hole in it? No, if there was a hole in it, what would happen if there was a hole in
It
that
would
can?
spread all around the water.
The water to be brown, right? Yeah. So there's no hole. So that's a crazy phenomenon.
Like the materials like sugar and all the stuff that make up the Coke and maybe weighing it down more.
I just
So
flipped
now
up.
there,
Wait, I just flipped up.
you flipped it, and what happened? Oh,
Maybe because they probably just measured it wrong.
I'm trying to figure out why. I think it's because it's not having that reaction of like, oh, like it's inside the water and then like the current is all pushing it and then because look, when you like drop it in, no matter what, it just sinks straight down instead of like wobbling. So I think that because it wobbles, like the current starts to move and then makes it like stay upwards.
Well, actually, it doesn't really sink all the way down. Like for like the 2 seconds, it starts floating, then it falls. See,
if I were to put,
drop it in there, it like
let's just experiment
see,
with
it goes
something.
back up to float, and then it goes back down.
What if I were to put this in there? What do you think would happen?
I would think it
You want? Oh, okay. Go ahead. Yeah.
sink.
No, I don't want you to put it in yet. I want you guys to feel it. You can each handle it. And then I want you to vote. Show me your voters. You've got sink, Jamel? Okay. What's your prediction? Ooh. We got a sinker and a floater. All right. Let's go.
Let's go.
Oh!
Now the water's dirty.
Why do you think, that's okay, why do you think that bottle?
Well, it's made of plastic.
Well, it's made of plastic, okay.
It's not as heavy as the like cans. Like they're not as fully, like they're not fully floating, but like only the top part is like coming up, and like they're just like hovering basically over the ground a bit.
Okay.
But this one is like, it doesn't matter how hard you throw it in, it'll always float. I think it's because of the material.
What if I had a quarter?
Okay.
What do you think?
I think it would
Sink.
You think sink?
Mm-hmm.
You think float?
because of the light material.
You ready?
Uh-huh. Oh my god!
Oh,
Where's it at?
at the
Look through the
bottom.
water, you can see it.
It's at the bottom.
So, it's not. Why do you think something so small, like a quarter, will just sink so fast, and yet all of these cans and this bottle, they're floating at the top of the water?
Because the mass is like really different.
They use it out of I think all.
It's the mass. So you think
I'm thinking
that the quarter weighs more than the can of Coke?
Yeah.
Well, we can't. Our scale's broken, but let's do that test we did earlier. Let's take this out. I'm gonna mix that up. All right, which one's floating? This Diet Coke. I want you to hold both of these, and one in each hand, and we're gonna. What do you think? What do you think is heavier?
Well,
I'm actually
It's
starting
not-
to think that
the
this is
mass-
heavier.
the mass is not weight.
I think
you
it's
can't go
because
like
of the
that, just
material.
tell the mass.
Wait,
Like,
What do
isn't?
you do to tell the mass?
You have to have like certain materials. You can't use it with your hand.
I have a question. Isn't like
The weight is different.
coins made out of zinc or something?
I don't know.
But I think it's part of the material because in my hand I feel like weight pushing down. But not like you would put my hand down there, but like weight pushing down.
So gravity.
Maybe it might be like since it's so light that the gravity is able to just push it down faster, and it's because like it's light, but the gravity might be pushing it. Since it's so light, the gravity might just be pushing it. It might be just so easy for it to be pulled down.
Well, actually, I think heavy things are easier to clean out. Cause like if you drop that can of Coke, it'll probably drop faster.
is, the
If
more.
if it was in
Because
the
gravity is more powerful.
What's the difference between the coin and the Coke can? What's the major difference?
the
Size.
The size. Okay. So in terms of size, we're not talking weight, we're not talking mass, just in terms of size. Which one's bigger, which one's smaller?
The
Coke
is bigger than
The Coke is bigger than the coin. Okay. So these things are connected. The size and the weight. What you're looking at right now is the property of density.
I forgot about that.
Yeah. So what's density? Have anyone ever heard the word density?
Yeah,
Yeah,
but I think
I
it means
learned
like
it like 2 months ago.
something about like how
It's
breakable it
I know
is
what
or
it
something.
is. I know the equation for it.
You know the equation? Let's hear the
It's
equation.
mass divided by volume.
Okay. Mass divided by volume.
Wait.
But we can't calculate
I
the
think
mass
this
and the
does.
volume, so
Let's
count.
think about it.
I'm not-
We don't have our scale, so we can't do mass. No, and we don't have anything to do with volume right now.
Wait, I have a question.
Just think about what you said. Mass divided by volume. So now look at the Diet Coke and look at the coin.
the Coke has more volume.
Who
than the
had?
volume.
Aha. The
So
Coke
you're dividing-
has more volume.
You're dividing this mass by the volume to make. You're dividing the mass around like the aluminum mass.
What happens if you have a big number in your denominator when you're doing division?
So volume.
Like the volume. If the volume is larger, what does it do to the value of density?
Nothing.
No, you just told me give me the equation one more time.
Mass and volume. Like,
Mass divided by volume, okay. If you've got a large volume, are you going to have a large density or a small density? Think about the equation.
a large
Small.
density.
A large. Why do you think a large density? You talk first.
Because you have,
could be
you have a bigger space, so say like the Coke, if you pour it in there, it's gonna be more spread out.
So you think because you have a larger volume, you should have a larger density. You said smaller. Why do you say smaller?
I say small because I'm thinking that since like it's a small number.
What's a small number?
No, wait, no.
So remember-
I'm starting to agree with Jamari here because if it's bigger, it would make sense because if it's like if the if the mass is small,
I've got a calculator.
if the mass is small, then and if the volume is high, you would have to have a lot of numbers, or like a
All
big number.
Here's my calculator. Let's pick a number for volume. Is there a volume on that?
Yeah, I think so.
Let's see.
It's
The diet and regular.
some 12,
Fluid ounces.
yeah,
12 fluid
or
ounces.
355 milliliters.
355 milliliters. That's a large number. Is there any weight on that? We can't weigh it. It's the only thing.
But I have
It's
one
only
thing.
34 milligrams and 12
Wait, can I show you something?
Let's just pick the grams of sugar.
See,
Just so I can show you something.
see,
The
can I show you something?
grams.
When I took the quarter and I added it, it started to move the weight down. So I'm starting to think since it starts to sink, whenever you put it on the soda can, it would start to like fall down in a way.
I want to show you a calculation of density. Refresh my memory. What is the equation again?
Mass divided by volume.
What's the mass of the sugar? We're just going to use the sugar so we have a starting point. Alrighty, 39 grams. And we're going to divide, right?
Mhm.
What did we say the volume was?
12 fluid ounces.
12 fluid ounces. Let's do we're not doing fluid ounces. So when you're doing,
Milliliters?
let's do the milliliters.
355.
353. Say it again. I'm sorry.
355 milliliters.
Look at that number.
You have to round that.
Look at that number. Read off the first few numbers.
10.
The very first one. Don't forget the zero.
1,
0 point.
0.109.
Yes. That's less than 1. That's a fraction.
That's a huge
So,
fraction.
I'm going to ask you again. If you've got a very large density,
You'll get
are you
a
gonna have
very
a-
small number.
yes.
Oh, wait.
Absolutely.
The density of water is 1. So if it's bigger than that, it's going to float.
If the density's
This
larger
one's
than
going to
1,
sink. I mean, float.
you think that one's going to float.
Yeah. Because because it's less than 1.
Well, no, we only did the grams of sugar just to get an idea. That weighs more than 39 grams. I just wanted to show you what the effect density has, volume has on density. So you guys thought that a large volume meant a large density. But if you look at the actual equation, the density is mass over volume. So I don't know if you guys remember from your math classes working with fractions. When you have a very, think about a pizza, right? You have a whole pizza. Now if you divide it in half, that's 1/2, right? You each get a nice large piece, right? Nice big piece, you guys are hungry. What if you had 1/4? Now you gotta cut it into 4 slices. How big is your piece as big as it was when it was 1/2?
No.
What if I said 1/8? What if I cut it in 8 pieces?
It'll be way smaller.
So the bigger that number gets at the bottom, the smaller your pieces are. You see, so your number gets smaller by that denominator.
So it was like 109, so that's 109, 109.
And so can we sort of explain why we think we sort of talked about the can, why it floats, because it had such a large volume. Why do we think the quarter sunk?
Because of the density.
Yeah, that's the density, but
Because of the-
what about the density? Well, think about it again,
I
this
think
equation
it's
that we
because of
talked
how
about.
small how bigger the mass is on it, the
Uh-huh.
more the density is going to be smaller.
We're talking about quarter now.
Well, since the density of water is less than, is 1,
Mm-hmm.
and the quarter, say it was that, like 109,000.
What does that tell you about the mass and volume of your quarter?
That is less, and it will say.
What's less? Use some
Well,
terminology.
we don't know the quarter.
We don't know the mass or the volume. We're just theoretical.
But
Based on the fact that quarter
it's
sunk,
so
what
it
can we
has to be
say
over
about the
1.
mass? The density is over 1, correct. What does that say about the mass to volume ratio?
Well, the mass is over 1, and the volume is small.
The volume is small compared to the mass. That's correct. We're going to end here, guys. I would like to do a little more research on why one of our Coke cans floated and one sunk. I think that for a project, we should do some research on why both didn't sink, because we looked at the label. They're exactly the same, correct?
Yeah,
There's no holes. We said if there was holes, we'd have groundwater, right? I've got them out the same freezer at the same time, so they're same temperature. So I think that should be, yes, that's going to be your project, guys.
Okay.
Tomorrow I want a full report on why we think one sunk and one didn't. I think we're going to try to get that scale working so we can also test that. But thank you, gentlemen. You've been a great help.